product to sum and sum to product identities. Welcome back. You are still getting through. You are not yet done until it is done. Now, because they make it possible to rewrite a product as a sum, the identities for cos A plus B and cos A minus B and cos A minus B are used to derive a group of identities useful in calculus. Useful in calculus. Now, we know that cos A plus B will give you cos A cos B minus sin A sin B. And this one too will give you cos A, that is cos A, cos B minus, okay, you have plus sin A sin B. Very good. Very good. Now, with this, we can use this same idea to derive that for product to sum and sum to product identities. In what way? No problem. The first thing to do is to add, I'm going to call this equation 1 and this is equation 2. So first of all, let's add the two equations. So when you add this plus this, so equation 1 plus equation 2, we are going to get cos A plus B cos A minus B. Hope you can see that. Very good. And this will be equal to this plus this will give you 2 cos A cos B. And this plus this, 0. Alright. And that is going to give you 0. So, then we move on to make cos A cos B the subject. So when you make it the subject, that means that we need to get rid of these two. So we multiply both sides by half. So when you multiply by half, you are going to get cos A plus B plus cos A minus B, which is equal to cos A cos B. Very good. Very good. So we have derived the first identity for a product of cos A and cos B. And that is half of cos A plus B plus cos A minus B. In fact, if you know how to come out with it, it's not about achieving the formula. Oh. Alright, let's move on. So this is the first identity. This is the first identity. Never forget it. This is the first identity. Okay. Now, let's see what we are going to come out with it when we subtract. So this is by addition. Let's move on to, please, I'd like to clean it. What if we subtract? What are we going to get? Cos A plus B minus cos A minus. Now, this minus this, 0. Very good. This minus this gives 0. So now, this minus this gives negative 2 sin A cos B. A sin B. Sin B. Wow, wow, wow. So to get the product of A sine A, to get the product of sine A and sine B, we multiply through by negative half. And this gives cos A plus B minus cos A minus B to be equal to the negative half multiplying negative 2, it will go. So here becomes sine A sine B. Sine A sine B. So this is also going to be the formula for the product of sine A and sine B. That is when you have two different angles of sine. Now you know that we can distribute this. This one is the same as this to this, negative B, and this to this, negative form. This is the same as half cos A minus B minus half cos A plus B. This is the same as this. Or we can see that this is the same as this. Oh, wow. Nice. So that is equal to sine A, sine B. So when you subtract, that is what you're going to get. So now, now you can see that we have used the identity for cos A plus or minus B to get two identities, and that is the product of sine A and sine B and the product of cos A and cos B. Alright, what about the use of these two identities? Let me claim it. What about the use of we are deriving four identities here. Two is found with the help of cos A plus or minus B. What about sine A plus B and sine A minus B? What is that also going to give us? We know that this is sine A cos A minus, plus cos A sine B. This is sine A cos B minus cos A sine B. Very good. So, like what we did, equation 1, equation 2. So we add equation 1 to equation 2. So when we add, what are we going to get? That is sine A plus B plus sine A minus B. And this is going to be equal to, when you add this to this, you get 2 sine A cos B. And when you add this to this, you get 0. Alright! So this is going to give us the product of sine A and cos B. So you multiply this by half, you get sine A plus B. Sine A minus B. And this is sine A cos B. Very good. Very good. So the addition of the two formulas from sine A plus B and sine A minus B gives the identity of the product of sine A and cos B. Oh, I love this. I love it. Now, what if when we subtract? Make sure that you write all these proofs and all these identities down. So this one is the third proof. This one is the third proof. So that is the third proof. What will happen when we subtract? Sin A plus B, sin A minus B. This minus this, oh, nice one there, 0. And this is going to give us this minus this. All you can see that, so again, we get positive there. We get positive there. So that's going to give us 2 cos. Oh, please, the previous one that we saw, the one that we just saw, the third one, the third one or the second one, the one that we subtracted, that is the second formula. Please check that for me. That's not going to give you negative 2, it's rather going to give you 2 because it's going to be negative this minus this. So it's not negative 2. So please, the negative there, ignore it. Ignore the negative there. Sorry for that. Ignore the negative there. Thank you. And when you do that, you're going to get half cos A minus B minus cos A plus B. So do that for me. Thank you, and I hope you do it. Now this is going to give you cos A sin B. So for us to get the product of cos A sin B, we multiply through by half. And we get very good. And that is the formula for the fourth part. Oh, I love this, my God. So that is all. That is all for that. That is all for that. That is all for that. So that is 4 identities here. Now let's look at some examples relating to this proofs. Let's look at some examples relating to this proof. Alright, so now when you group the 4 formulas that we have derived for the product of cos A and cos B and the product of sin A and sin B, when you, and please don't forget that sin A cos B is not the same as, sorry, I'm coming. Sin A cos B is not the same as cos A sin B. Sin A cos B is not the same as cos A sin B. And also, cos A cos B is not the same as sin A sin B. I think that one is clear. It will be clear, but what most students take it to be the same is sin A cos B and cos A sin B. Please, these two, they are not the same. They are not the same. And when you combine these 4 formulas, you can see that it is product to sum. You see it because this will be equal to half, then something. You can see that what will be here is going to be sum of some what? Identities. Very good. So, or expression. So what we have just derived is product to sum. So let's look at how to use a product to sum identity to solve question. Very good. So we have to write cos 2 theta as the sum or difference of 2 functions. Now, here we are going to use the identity for cos A and sin B. Why is that so? The reason why we are using that is because we want to write cos 2a as the sum or difference of 2 functions. So here we are going to use cos 2 theta and sine theta. And you can see that this is not the same as this argument. This argument is not the same as this argument. So if this is A, this is going to be. So A is going to be 2 theta and B is going to be theta. Very good. So when you do the substitution, you're going to get half sine. Instead of A, we write 2 theta plus theta, then minus sine 2 theta minus theta. Alright, so that's what you're going to get for that. And then here you get half sine 3 theta minus sine theta. Very good. Very good. And that is going to be the expression that we are looking for. Alright, so from this new identity, we can derive another group of identities that are used to write sum of trigonometric functions as product. Very good. So this is cos 2 theta sine theta. So you can get a lot of it. Very good. So let me give you the formulas for sine, that is sum to product identity. The first four we derived is product to sum. So now let me give you the sum to product. But because of time, I may not be proving it for you. Let me give you the formulas to write. So that's the formula. So you can see that it's a sum to product. You see, this side we have a product on this side, and this one is sum or difference. Alright. So sum or difference, then the product. That is what this also means. Alright. So you'll be looking at using a sum to product identity to solve some questions. So let's look at our first question. So the first question we're going to look at, right? We are going to write sine 2 theta minus sine theta as a product of two functions. 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 Very good. Very good. So, looking at the formulas we have, to the one that you can relate to 2 theta minus sine theta is going to be, you see, sine, but the arguments are not the same. So that one is going to give you 2 cos. Now instead of A, you write 2 theta plus 2 theta plus oh, theta rather plus, sorry, it's a mistake. Here is 4 theta. That place is 4 theta. So by substitution, so this is our A, 4 theta is our B. So we get 2 theta plus 4 theta over 2. Then sine 2 theta minus 4 theta over 2. Alright, so that's going to be for that. Then this is 2 cos 6 theta over 2, 6 theta over 2 sine negative 2 theta over 2. Alright, and this is going to give us 2 cos 3 theta sine negative theta. And we all know that this is an odd function, so this is going to give us 2 cos 3 theta sine theta. So this is going to be the expression. This is going to be the expression, and this can be said to be an identity. Very good. So that's all. In our next video, thank you. In our next video, we are going to look at half angle identity. And trust me, you are going to love it. Thank you.